All right, for question number three. So again, we have the little friction equation up there. We might be able to use it. We'll see. Let's go ahead and draw the picture right here. So this is 20-degree incline, and we have the file cabinet right here. So let's go ahead and label all the forces. It is it's not moving, right? So it's tilted but not moving. Okay, so if you go ahead and draw all the forces, we will have the gravitational force in these two directions, FGY and FGH. Okay, because it's on an incline, it is going to change direction. And because it's on a surface, we are also going to have the normal force that's perpendicular to the surface. And of course, we've got ourselves friction. And this will be a static friction right here. Okay. Any question about the free body diagram? Yes. Doesn't matter. Okay. As long as you have these, it doesn't matter how you draw your incline. As long as you have these these four forces. Yes, the FGX is parallel to the incline. Okay, that's your FG, well, quote unquote X direction, but it's not strictly horizontal, but it's just horizontal compared in reference to the plane. Okay, now I like to draw it this way for one reason, because when I want, well, if the object is going to slide, it slides to the right. That's the positive direction. So that's the reason why I draw it this way. Now, it says what? What is the magnitude of the static friction force? And we should know something at the moment, and that is, if I want to find out this force of friction, it must equal to what? FGX, but in the opposite direction, right? So can we go ahead and find out what FGX is? What's FG in the X direction? FG will be M times G, right? But it's inclined, it's tilted. How would that change? FGX will be M times, which one? Sine. Mg sine theta. Okay? Mg sine theta. And the mass is 50 kilograms and 9.8 meters per second. Now, I'm not going to use the negative in this case because going to the right is my forward positive. So I'm going to drop the negative sign right there. Okay, 50 times 9.8, sine 20 degrees. So 50 times 9.8 times sine of 20 degrees. You should get an answer, and that is 168 newtons. Okay, so going forward, okay, the force due to gravity in the x direction is 168 newtons, and therefore the frictional force must be going in the opposite direction over the same magnitude. Okay. You good? Right now, so the next part is a bit more challenging, and I want to go ahead and explain a bit more about the second part of the question. Now, it says, at what angle will the file cabinet begin to slide? Okay, so now, there's one piece of data I should give it to you. That's not on the paper yet, and that is this. I need to give you the coefficient of friction. So as you can see right here, come on, come on. Wait, hold on 1 second. So if you look at this table, I hope I can export this table over here. Hi. Why doesn't let me go? I'll get the table over in just a moment, I guess. Yeah, here we go. Oh, yeah. So if you take a look at the static and kinetic friction, the coefficient of static friction and kinetic friction, one thing that you should see consistently is that the coefficient of static friction is always greater than the coefficient of kinetic friction, which means that it is always more challenging to start moving an object than to keep an object moving at a constant velocity. Okay? And as we know, ice is very slippery, and therefore it also has a very, very small coefficient of friction. And why do we use rubber to make car tires? Because it gives us the greatest coefficient of friction. Okay? And for our question right here, we are going to use 0.8. Okay? That will be the coefficient of friction of interest. Yeah, it's not given, so I have to give it to you. Yeah. So when you do your problems, if you are not finding the coefficient of friction, then they will have to give it to you. So don't worry about it. So now, at what angle will the file cabinet begin to slide? So this is about our concept of the maximum friction. So what we're saying is, yeah, so you want to find out at what angle, not 20 degrees, likely. You want to find out what angle it is so that your FGX is going to be slightly greater than your static friction. Okay, because if that is the case, it will begin to move. Okay, so if this force is greater than this force, then we will see the file cabinet sliding. So we say, all right, well, let's set up the relationship here. So that means we have the force of friction. It's going to equal to the FGX. Okay, or yeah, let's find out what that angle is. Now, the following part is going to involve some algebra work that you might not have seen in the past. So I want you to bear with me and just look at it. If you have a question, make sure you stop me and ask the question, okay? Well, how do we calculate our static friction? And we say, well, we have the equation, remember? The mu times normal force, right? And we say, oh, yeah, how about FGX? Oh, we just calculated FG of x, right? It's mg sine theta. So far, so good? Okay. Now, again, we are not dealing with anything in numbers. We are just playing with the algebra right here. Well, we know the coefficient of friction, that's 0.8. Okay. I mean, we can put in some numbers, but hey, what about the normal force? Well, normal force is what? It's going to be the opposite of FGY, right? Well, FGX is mg sine theta. FGY will be mg cosine theta, right? So mu s will be multiplied by mg cosine theta. All right, all right. Are we okay so far? Can you see something that can be canceled out? mg, all right? So we say, oh, yeah, mg's duplicated, right? You have mg on both sides, so please go ahead and eliminate it. So we have mu times cosine theta is equal to sine theta. And something that you will learn in pre-calculus soon is that mu s is going to be sine theta over cosine theta. And what I said about pre-calculus is that if you see sine theta over cosine theta, that is equal to tangent theta. All right, so let me pause a moment to make sure that you know what's happening. Okay. Are we good so far? Are we good? Now, before we do our final calculation, let me intervene with one little curious question. The curious question could be like this. Some students would ask, hey, Mr. Jan, we calculated 168 earlier, right? Can we just put the 168 over here? Can we? Why not? So first, we're looking for an angle. And second, that 168 newtons is valid when the angle is 20 degrees. Do we know what the angle is? We don't know the angle. So please make sure that you don't give in to the temptation of substituting these numbers prematurely. You cannot substitute. So therefore, we will go ahead and find out what theta is by doing the inverse tangent of the coefficient of friction. So you will go ahead and again, it is the inverse tangent, not just the tangent, but the inverse tangent. So on your calculator, you would do inverse tangent and make sure that it is in the correct mode. It's in the degree mode. And that should give you 38.7 degrees, or you can just say 39 degrees. Okay, depending on how your teacher asks for the number of significant figures. If it's 2, then you just write down 39 degrees. Okay. Now, I personally, I think part B is challenging. Part B is pretty challenging because you've got to acknowledge how two forces are equal to each other, and you have to acknowledge that you don't have any numbers to play with, so you can only play with the algebra, play with the terms, and you simplify the terms, and that's the experience that I hope that I can share with you with this problem. Okay? Good.